Alright, hello everybody. Welcome back to Chan's Academy after a winter break in the first semester. So I just wanted to start off with kind of stuff we talked about in class. We talked about SARS, which is one of the more recent outbreaks of a virus, and it made sense to talk about it because it's something that we can see exponentially. Like it grew exponentially. Okay, so it was an exponential function. So SARS was a virus. It killed almost about 10% of the people infected. It was a pretty big deal in 2003. So I googled up an image and I found this chart of the number of people who became infected. So you could see that you start off really kind of like 1 people to light amount, and then it keeps going up and up. So this is what we call our exponential, is that you might start off really slow, like 1 person, but then suddenly they cough and get a bunch of people sick. Those people end up coughing and getting more people sick. And they kind of sound like me, I'm sick, so they just cough everywhere. And you just keep increasing the number amount. So right here, this is exponential. And not everything's gonna keep going and blowing out of proportion, because eventually they had people contained. They put them in areas that they couldn't move. I don't know if you guys seen quarantine. They lock you up in a building. You can't leave. And that's when it started going back down. But the beginning would be exponential. Okay, so let's talk about the exponential problems that you're gonna have. So for your Chan Academy 2 questions on your homework, here are the 2 questions. For A, I want you to do this: y equals 2 to the power of x plus 3, and I want you to solve for y using x equals 1. And for B, y equals 2 to the power of x minus 3, solve for y for x equals 1. Okay, so what you do is you plug in 1, and that'll become 2 to the power of 4. And this one, plug in 1, 2 to the power of negative 2. Alright, and let's move on into some examples. Alright, so I put up 2 examples that should help you on your homework, and we can look at them, and it'll pretty much be exactly like your homework. Alright, so we have 2 exponential functions, right? And remember, they called exponential because you have something to the exponent, right? Alright, so 3 to the power of x. So what we normally do to graph these is, that we keep it easy. We just plot out some points. So let's plug in negative 3. When you plug in negative 3, you get 3 to the power of negative 3. 3 to the power of negative 3. And you guys have to remember that negative exponents create the reciprocal. 1 over 3 to the positive 3. Okay, 3 to the power of 3 is 27, so that gives you 1 over 27. Alright, and then negative 2, that's going to give you 1 over 9. And a lot of mistakes I see people do is that they make this negative, but no, remember, if it's 3 to the negative 3, that changes to 1 over 3 to the third. There's no negatives involved here, right? Negative 1, you get 1 over 3. Anything to the power 0, 3 to the power 0 gives you 1. 1 to the 3 to the power 1 gives you 3. 3 to the power of 2 gives you 9. And 3 to the power of 3 gives you 27. And if you notice something, you see that you have the reciprocals going on here, right? 1 over 27, 27. 9, 1 over 9. 1/3 and 3. And this guy's just by himself. Okay, and I'm going to go ahead and do the same for this one. So if I do negative 3, I get 3 to the power of negative 3 plus 1. So that's 3 to the power of negative 3 plus 1. And that's y equals. Alright, so that gives me negative 3 plus 1, 3 to the power of negative 2. Okay. And that should be 1 over 9. Okay, that gives me 1/9. What do you think the next one's going to give me? When I plug it in, I get 1/3. When I plug in negative 1, I get 1. When I plug in 0, I get 3. When I plug in 1, I get 9, then I get 27, and then finally I get 81. Okay. Alright, so let's look at the Desmos and let's check to see what it looks like. So we had y is equal to 3 to the power of x. Okay, and you can look at some points here. Let's look at the points we made. We got negative 3 comma 1 over 27. Yeah, that's right. And then we had negative 2 comma 1 over 9. Yeah, that's right. Negative 1 and 1 over 3. 0 and 1. 1 and 3. 2 and 9. And then 3 and 27. So what we would do is we would have these points, right? You see these points, and you would just kind of, you know, the exponentials look like this, going across, and then growing up faster. Okay, so if we zoom out, we can see it. It's gonna always get really close to 0, but I'll show you that it never actually touches 0. So let's zoom into something like 50-ish, and right now it looks like it's touching it, but as we keep zooming in and keep zooming in and keep zooming in and maybe even keep zooming in, oh, it's gonna take a while. Alright, so as you keep zooming in, you're gonna realize that it doesn't actually touch the 0. Maybe it wasn't the best demonstration, but you'd have to zoom in really close to see that it doesn't actually touch it. Alright, so I just wanted to show you guys again. Sorry, 50 was a little bit too far. It would make me like have to zoom in for a long time. So I just stuck to close to like 4, or sorry, negative 4. You're gonna see it right here that even though it looks like it's close to 0, there's actually like space between there. And even if you move farther to the left, it just has space. Okay, but when you zoom out, it's gonna look like it touches 0, but it doesn't. Okay. Alright, so there's our first one, and let's go ahead and plot our next one. We have y is equal to 3 to the power of x plus 1. And let me try to fix that here. The power of x plus 1. Okay, so this is the purple line, and in your homework it's going to ask you what happens if I add a plus 1 right here on the exponent. Well, if you guys look at this, what happened here? So we had 0 and 1. Well, that became 0 and 3, and that relates to 1 and 3. Okay, so what happened is that it shifted. Which direction did it shift? Well, this, the green, the parent function, the original, it moved to the left 1. So by adding 1, you've moved everything to the left 1. Okay, so let's see if we do it to another one. Y is equal to 3 to the power 3 to the power of x plus 2, and that moves it twice over, right? Instead of it being over here, this green one, it moved it over twice to the left. So what do you think would happen if I did y is equal to 3 to the power of x minus 1? Well, it's just going to move it to the right 1. See how that black line moved it? The original was green, and it moved it to the right 1. Okay, so that's part of your homework, and that's the answer, is that you can see these translation. You have your original, and it's moving over left or right based on if you're adding or subtracting 1, 2, 3, okay, and on and on. Okay, other sorts of things would be the stretching, and let's look at the stretching. If I did something like multiplied this by 2, okay, now everything's doubled. If I multiplied it by 5, it's now 5 times as much for every value. Or if I took this, and if I wanted to move it down, then I would subtract something like 10. Then it's moved down 10 spaces. Okay, and that's moving it up or down, or stretching it, or compressing it. Okay, so there's a couple things you can do. You can move it left or right, stretch and compress, or you can just move it up and down. Okay, so lastly would be the domain and range, in case you guys are forgetting that one. Exponential functions have a domain, which is the x, that's always all real numbers, because they can move left and right, doesn't matter. If I zoom out, I can still find something on the left and right. I can keep moving left and right. Okay, see that? Okay, so I know this like graph looks like it just keeps going up, but if I moved out to here, it would be off the screen, right? There would be something like really way up high, but you would still be able to find it. So the domain, when you're sweeping left and right, you can say all real numbers. Now the range, if we're going up and down, okay, or sorry, from bottom to up, right now there's nothing at the bottom. The only time you'll get it is right here, when it's about 0, but it never actually touches 0. So the range for this one is y is greater than 0, and you just keep going up, because you can keep touching something as you're moving up. And I know it's sorry it's a longer video, but it's covering our basics and we need it. Okay. Alright, so there will be a homework check. I'm going to check your homework very thoroughly, and we're probably going to do some sort of punishment if you don't have homework. So I hope you guys finish this homework. Email me if you have questions, and I'll see you guys in class.